Alright guys, real quick before we start our new lesson, I actually want to show you something cool about centroids that I should have showed you yesterday. So the centroid is actually the balancing point of a triangle, and I'm going to show you that with this little triangle I've got. I just got a note card and I cut it into a triangle. So we're going to construct the centroid of this triangle, and then I'm going to show you that I can balance it on anything, like the tip of my finger or a pin or something, okay? So the centroid is created by the medians, and the medians are the midpoint to a vertex. So to find the medians, I'm actually going to fold this in half to get the midpoint, okay? And if I don't do it perfect, by the way, this will not balance. So I got to be very careful and do it just right. Okay, so there's the midpoint of this. I folded it in half. Right, there's the midpoint. And I'm going to draw it to the opposite vertex here. All I'm going to do is create that point that shows me where the center balance is. Okay, I'm going to fold this section in half now to get this midpoint. Okay, there's that midpoint. I'm really going to have to unfold it so it will actually balance, but then I'm going to draw it here. I just think this is something that's kind of cool to see. So here should be the centroid. The centroid is where I should be able to balance it. I'm going to have to flatten this out some so that it'll actually balance. But what I'm going to do is stick my finger right here on this and balance it. As long as I've done it. There we go. That is the center of balance. I'll show you under the thing. I'm balancing this on my finger because I created that center of balance. So it's kind of cool. You try it on your own, but I've got it balanced right on my finger. Okay. Anyway, let's move on to the actual new lesson we're learning today, and that is the fourth and final triangle center, which is an ortho center. Okay. So we got a little half piece paper foldable today. This one's kind of shorter because we've only got a little half one here. All right. We got our nice little foldable right here. Okay. So an altitude of a triangle is a perpendicular segment from a vertex to the line containing the opposite side. The orthocenter, which is our fourth triangle center, is the point of concurrency for the altitudes. An altitude can be outside, and it is outside in an obtuse triangle. Example 3 says, find the orthocenter of the triangle by graphing the perpendicular lines to the sides of the triangle. Here is how this is going to work. I have to find, and they've drawn one of them for us, the perpendicular line from the vertex. So if I'm finding a perpendicular line from P to the opposite side, which is OQ, I look at OQ's slope. OQ has a slope of 0 because it's a horizontal line. I have to find the perpendicular slope. The perpendicular slope is the opposite reciprocal. The opposite reciprocal of 0 is undefined. So you've got 0 slope, you've got undefined slope. So that's why or where we're going to draw a vertical line, which is they've already got it for you, but I wanted you to understand exactly where they have this from. So there's our first altitude. It goes from P to this line down here, OQ. Let's pick another one. Just like the others, we only have to have 2 of these segments to make it. Now 3 exist and you could draw all 3 of them, but the only reason that you have to draw 2 of them is because if you've done it correctly, the third one would meet at the exact same point anyway. Okay. So now let's find the slope of another one. We can either choose PO or PQ. It doesn't matter. I'm going to choose PO. So we're looking for the slope of PO. So the slope of PO goes up 1, 2, 3 over 1. Up 3 over 1. But I have to find the perpendicular slope. The perpendicular is the opposite, so negative. The reciprocal, so 1/3. So what I'm going to do is I'm going to start at the opposite point, which is Q, because it's not listed in here. And I'm going to go down 1 over 3. I can't do that, so I'm going to go up 1, left 3, and then I'm going to draw that segment. Make sure I do it accurately. Wherever these two cross is the orthocenter. So my orthocenter is right here. The orthocenter is 2, 2. Okay. Pause the video and try B on your own there. And then we will go over it together. Just trying to put something up in my drawers. My desk drawers are messed up. Okay, so we are finding the slope, and then we are going from the opposite vertex. So let's find the slope of AB. Up 1 over 1, up 1 over 1. So the slope is 1 over 1, or just 1. Perpendicular slope is the opposite, so negative. Reciprocal, well, when you flip 1 over 1, it's 1 over 1. Okay? Now, here's AB. We are going to start at C then and go down 1 over 1 and draw that segment. Okay, there's our first altitude. Altitudes, remember, go from the vertex to the line, and they have it there perpendicular right there. Okay, let's do another side. Doesn't matter which. Let's do AC. AC is up 1 over 1, 2. Up 1 over 2. So the opposite is negative. The reciprocal is 2 over 1. So AC, the opposite is B. We go from B and go down 2 over 1. And we're going to draw a segment there. I got off. Do you see right here where I got off? I gotta erase that. Make sure, don't do like I just did. Make sure you draw it all the way, like, I'll show you what I mean. I was supposed to go down 2 over 1, and then down 2 over 1, and then down 2 over 1, so it would have connected here. But because I didn't keep going, I got off slightly. Oh, no. I went down 3 over 1. I'm going to have to go back and check all this, by the way. Down 1, down 1, down 1, down 1. Yeah, there we go. Okay. Sorry about that. I'm just checking because I'm worried I've made another mistake somehow. I did make another mistake. It's not this one. This one is fine. This one is not, and it's the slope. I'm gonna erase it. Start over, and I'll show you what I mean by here's my mistake. Very sorry. Okay, let's go back here and count the slope for real. Do you see how it doesn't actually cross right here? So it's not 1/2. It's 1. We're just going to count from A to C. 1, 2, 3 over 1, 2, 3, 4, 5, 6, 7. It's 3/7. Make sure that you don't do what I did and count wrong, which means it would be -7/3. Very sorry about that, but everybody makes mistakes. You got to go back and check them and fix them. Okay, so now from B, let's count down 7/3. Down 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3. There we go. That would be better. I knew what the answer was supposed to be, and I know you didn't, but I was like, that is not right. All right, there we go. So in the future, just count the whole length of the segment slope. You can reduce if you need to. It just will evidently help because you might make a simple mistake like I did. The ortho center is here. Which is 9, -1. Now notice, this is acute. The orthocenter is inside. This is obtuse. The orthocenter is outside. We don't have a right triangle, but we'll talk about what that would look like. We'll switch over to Geogebra real quick to show you what that would look like. I should have had that open and did it. Okay, so I'm just going to draw a triangle here. I'm going to have the measurements just so you can see. Remember, this is free. It's called Geogebra. Right here, Geogebra. Okay, angles, we're going to measure them just so you can see if we've got acute, obtuse, or a right triangle. Try to make this thing bigger so we can actually just see. Okay, and then I'm going to construct the orthocenter. Now the orthocenter is perpendicular to the opposite side through this vertex. So I want a perpendicular line from here to there. That's perpendicular. That's the orthocenter. I mean, not the orthocenter, an altitude. From here to here, and from here to here. This point is the orthocenter. I just did an extra point, but that's okay. All right, so this is acute. It is inside. I'm going to move it around till it's not acute. Oh, look, right there. 90. I can't get it quite right. When it's very close to 90, when it is a right triangle, the orthocenter is at the vertex of the right angle. When it is larger, when it's an obtuse triangle, the orthocenter is outside of the triangle. So that's what we needed to see. Okay, so we're going to write that down in our notes. In your notebook, on page 69, we titled it yesterday, and if you didn't, you need to do that now. Glue this to the top, and then we're going to put the locations right underneath this in the very small space you got left in your notebook at the bottom. So we'll glue this in on page 69, and then we'll work on anything else. Okay, so the orthocenter locations. It is important you know these locations. You're going to be asked that on some quizzes, graded assignments, whatever else. When it is acute, it is inside. When it is right, it is on the right angle. And when it is obtuse, it is outside. Y'all can't spell outside, evidently. Okay, so inside, on the right angle, outside. Okay, we've done 4 triangle centers. We have done circumcenter, which has inside, hypotenuse, outside. We have done in center, which is always inside, in center, inside. We have done centroid. Troid is always inside. And orthocenter is inside on the right angle outside. So the two that you can find the word in are the two that are always on the inside. Of course, centroid doesn't have the correct spelling of the in, but you could force it and make it the in. All right. Okay, so that's the end of our triangle centers lesson. We're really going to review those in the coming lesson.